Concept 2, finding equations of direct variation. Alright, so when you are told you have a direct variation line, and you're given any point on that line, you can find the equation, which is really just the constant of variation, the slope of that line, by plugging in your x and y values, okay, and solving for k, solving for your constant of variation. Alright, so I have, I want to find the equation of direct variation for when y equals 36 and x is 9. Okay, I would plug in 36 for x, got my k, and I'm multiplying that by 9. Alright, I'm trying to solve by k, or solve for k, so I need to divide by 9. Divide by 9. This will cancel, and I'll have 36 over 9 equals k, or k is equal to 36 over 9, or 4, when I simplify my fraction. Okay? So that works, and you can always do that whole, all those steps. However, it is good to recognize that if this is my y, this 36, and this is my x, that 9, I can also write this equation as y over x is equal to k. So when I'm given my points, I can plug them directly into this form. Okay, I can plug them directly into just a division. Okay, so I basically have 48 divided by 6 is equal to k. And if I simplify this, well, 6 times 8 is 48, so k is equal to 8. Alright? It makes this very simple and straightforward. Okay? Y is 65 when x is 13. 65 divided by 13 is equal to k. If we divide both of these by 13, we'll get 5. So k is equal to 5. All right. We're not always going to have a whole number as our coefficient, right, as our slope. So if y is smaller, y is 4, when x is 56, that's equal to k. 4 over 56 is the same as 1 over 56 divided by 4, which is going to be 14. Okay, so 1/14 would be equal to k. And all of these, when I'm asked to write my my direct variation equation, are going to be written out as y equals, in this case, 5x. Y equals 1 over 14x. Okay? Or this one, where I have negative 3 over 27 is equal to k, which is equal to, divide both by 3, I get a negative 1/9. Right? And that would be y equals negative 1/9 x. Okay? That's all there is to it for these ones. Sometimes you'll be given a table, right, with a lot of different points. You can choose any one of those points. If it is a direct variation equation, they'll all give you the same coefficient, and you'll be able to make the equation the same way.